Hello all, welcome back to Code Hub. Today let us solve the lead codes daily challenge. The problem is find all anagrams in a string. Given two strings yes and p, return an array of all the start indices of p's anagrams in yes. You may return the answer in any order. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So what does that mean? So let us say the example. The string yes is this one, c b a e b a b a c d, and the string p is a b c, where a occurs once, b occurs once, and c occurs once. So we want to find the list of start indices such that it should contain an anagram of p. So to find all the substrings of length of p, what we can do is we can try a brute force approach. For each and every index we can we can have another for loop, nested for loop, which runs for a size of length p, and we can find the occurrences of the both the substrings, and finally we can just check whether it is an anagram or not, and we can just put that particular index if it forms an anagram. But what we can do to optimize the time complexity, so the time complexity will be n square, and another for loop for checking the whether it is an anagram, it can be having a length m, so the time complexity will be order of n square into m. So can we optimize this approach? Yes, we can optimize. We can use a actually we can use a sliding window technique here. How it is done is we are going to find a length of 3 to length of 3. We want to take a substring of length 3 from the string yes, from the starting from the index 0, and the next the character which is at the fourth position is going to be added, and the first character that c is going to be eliminated. That is what we can do in a sliding window technique. So we actually what we can do is we can actually calculate the frequencies of all the characters based on the window size, and we can eliminate the starting character, and we can add the next character for the next iteration, and such a way that what we can do is we can reduce the time complexity time complexity a large. But we want to check whether it is an anagram. For checking whether it is an anagram, what we can do is we can have a map which is going to store the frequencies of all the characters in that substring yes, and all the characters which is we want to have it in p. So that is going to be an order of 26. Since there is going to be only lowercase characters, we can just have an order of 26. So for each and every index of while we are adding a character, we will run a for loop for checking whether it is an anagram or not. That is going to be a constant time. So that overall time complexity will be boiling down to order of n, where n will be the length of the string yes, and for the space complexity will be in order of 1 if we consider that is going to have order of 26 space, else we can say order of 26. So if we can just quickly code the approach so that you can get an understanding. Indices, and we also need a map that is going to store frequency of yes of 26, which is going to be initialized to 0, and int frequency of p, that is of 26, this is going to initialize to 0. First we can just go for every characters in p, and we can store the frequency of p. Next what we can do is we can just for int I equals to 0, where we can take the size of the length. Int n is equal to s dot size, and int m is equal to p dot size. For int I equals to 0, I lesser than n I plus plus. If I is going to be greater than size m, then greater than or equal to size m, then only we want to start checking whether that substring is an anagram or not. Until then, we can just we can calculate the frequency of the character which is in yes. So s of I minus a plus plus. So the total length of string p is going to be 3, and while starting from the index 0, 0, 1, 2, 0, 1, 2, and we are going to check what we are going to do is we can take this we are going to track the frequency, right? We can just keep it outside itself. For each and every character, we are going to add the current character into our map, and if I is going to be greater than or equals to m minus 1, m minus 1 is nothing but 3 minus 1, which is 2, 0, 1, and 2. When we have the characters that are greater than or equals to m, obviously at that point of time we can try to check whether it is an anagram or not. So now we can check anagram. We can call the function check anagram, and we can pass the two frequency maps, frequency s and frequency p. And if this becomes true, what we can try to do is we can have it. If this going to be true, this check anagram function is going to return me true. Indices dot pushback of the starting index. How we can calculate the starting index? The current index minus m plus 1. So what does that mean? So the current index is going to be 0, 1, 2. 2 minus m is nothing but 3 plus 1, which is going to be 2 minus 3 minus 1 minus 1 plus 1, which is going to be equals to 0. So we can calculate the starting index by this formula I minus m plus 1. Since it is going to be 0 based indexing, this is going to be the formula. If it is going to give us an anagram, it is going to we can just put the starting index. What we have to do next is whenever in the next iteration we are going to add the character a. Whenever we are going to add the character a, we want to subtract the character which is going to be at the starting position. So what we can do is frequency. So what we can go do is, once this if loop gets completed, we can just decrement the character that is at the start position for the next iteration, because we are going as a sliding window. So we are going to decrement the character from here, and we are going to increment the character for the next iteration, which is going to be here. So frequency of s of I minus m plus 1 minus a minus minus, so that in the next iteration when e is getting added, we will be calculating the substring BAE, and we will be checking whether it is an anagram or not. So now we are going to write the function for the anagram. Bool check anagram, that going to take two arrays in frequency s and in frequency p. And what we can do is we can run a for loop for int I equals to 0, I lesser than 26, I plus plus. If my frequency s of I is not equals to frequency p of I, then return false, else we can just return true. So now let us try to run our code. At the end of the day, we are going to return the indices. vector. So now we can just try to run our code. Great, it gets accepted for both the test cases. Let us submit the code as well. Superb, it gets submitted. So the time complexity will be order of n and the space complexity will be an order of, so yeah, 26 or order of 1. So hope you like this problem. So let us see in tomorrow's LeetCode daily challenge. Until then, bye.